Thank you, John, for presenting everything. And I just don't, I think my project just presentation leads into it. So thanks a lot. And that was very clear. These are my disclosures. I will skip over the results of some of the things that we discussed. I think it was presented earlier, so I'll just skip over this. Mainly, what is the reverse causality is because of being at high risk of obesity, type 2 diabetes, CVD leads to increased intake of local sweeteners or local sweetener beverages as a risk reduction strategy. So that's mainly what the issue is. And prevalent analysis in cohort studies cannot capture that. In prevalent analysis, the assumption is that you fill a food frequency questionnaire and you say that you are having locally sweetened beverage, for example. The assumption is that that's your usual intake and it's been your usual intake for a long time. But it might not be true because that person might be having high sugar intake previously, and that has changed because of risk factors. The doctor told them, or they are having some of these disease risk increase or have the disease. So I think a lot of, we actually wrote about this many times. John mentioned this. There are robust methods which are control for this, and John covered this, so I will just go ahead. And this was I'm showing you, this is the Jen Lee's paper where substitution analysis is given. I'm giving you this analysis with the green is when the substitution of local sweetener beverage is done with the sugar sweetener beverages. The greens one are where we see a benefit. I'm showing this because later on it will, when I show the mega cohorts update, it will be a similar figure. But John presented this, so I will not go in detail on this. And then let's discuss the mega cohorts project. So we did that paper, but a number of studies, if you look at the number of studies we have here, like 5, maximum 6, 5, many of them were one cohort. So that's the problem. We do not have, we have a number of, the cohorts are very large. So many of the much of the data comes from Harvard cohorts, which are larger in size. So we are quite confident in the results. However, the number of cohorts which have the data that we can use is there, but that data is not published. So Mega Cohorts project is a project that is funded by Diabetes Canada. And our aim is to use these robust methods, which is the change analysis and substitution analysis in large cohort studies. Large means more than 100,000 people in size. And this would be similar to our Lancet Diabetes Endocrinology paper, which was led by Dr. David Jenkins on the GI and GL work, where he collected data from these large cohorts, and it makes into a very impactful paper. And the advantage is that you'll get consistent results, very high statistical power. By doing robust analysis, we'll reduce confounding. We'll also be able to look at rare outcomes, and some of those prioritized health outcomes, we have only one cohort or none at all. And by publishing this, we can increase the weight of the evidence where possibly WHO can later on revisit this question and harmonize the guidelines later on, hopefully. And our approach is to approach these big cohorts and pool their data using IPD, which is individual participant meta-analysis or federated meta-analysis. And the objectives is to estimate substitution impact, which is the substitution analysis that we already did for the previous paper, but this will be in mega cohorts. For locally sweetened beverages with SSBs, water for SSBs with standard of care, and then locally sweetened beverage for water, which is reference. Then assess change analysis, which changes NSP intake, with type 2 diabetes and other health outcomes. So all these health outcomes are prioritized health outcomes which were mentioned by the WHO, uh, by the WHO meta-analysis and their guidelines. So we're focusing on those outcomes. And we will also evaluate baseline associations. So then compare the baseline or naive analysis compared to the robust analysis. So we call substitution and change analysis as robust analysis and the baseline association as naive analysis in the context of local risk sweeteners. So these are some of the advantages because of the large size, and I'll show you a list of the mega cohorts afterwards. There's a lot of things that we can do with an IPD analysis. We can do a comprehensive sensitivity analysis, for example, by sex, gender, race, ethnicity, BMI, socioeconomic status, diet, quality. We are approaching many of these big cohorts and we're asking them for they can either give us data or they can give us summary data, and we can then combine it as a two-stage model using a federated meta-analysis. And we also plan to do a dose response modeling where the number of beverages changed or exchanged, is that something that is important or not. So where are we right now? So we are trying to bring the consortium together. Currently, we applied for funding when we had 7 cohorts on board, which have 1.66 million participants. There's a meta-substitution analysis, which I'll present today, which is based upon the published studies of these cohorts, and we put that data together. We are still trying to engage with other cohorts, and possibly there are 15 cohorts that we can engage with. And then we'll try to get their data or try to help them analyze the results and pool them. And then year 3, plan to do a data analysis and manuscript. So these are the large mega cohorts, which are more than 100,000 people in size. These are from the Richard Doll Consortium. And the tick mark means that, there's a cohort list, then the countries, then the size. SSB tick mark means that the SSB data is present in that cohort. NSB tick mark means the NSB data is present in that cohort. Some of the cohorts says we do not have that data, for example, Shanghai Women Health Study, so we can't use that. Substitution means that they have published substitution analysis. And after that, there are health outcomes, type 2 diabetes, CVD, adiposity, cancer, mortality. In that, the tick mark means the data is present. Dot means they have published it. So if the first dot is SSB data is published for that outcome, second dot means NSB data is published for that outcome, red dot means substitution analysis is published for that outcome, and you can see that majority, Harvard cohorts lead that effort. Harvard cohorts have adiposity, which I forgot here, but also we have very few other cohorts, EPIC cohorts, Nutrinet Sante, and Lifeline cohort, which have published a substitution analysis. The rest of the cohorts have not published substitution analysis for these outcomes. They might have published in other outcomes, but not for these outcomes. There might be some missing, but this is we did a systematic review of all the cohorts and tried to find all the studies. If anybody knows any other analysis that has been done, then please contact me. So I'll give an update of the meta-substitution analysis. So what is a meta-substitution analysis is at the moment, only 4 mega cohorts have published substitution analysis. And substitution analysis is you have the coefficient of the local risk sweetener and the sugar sweetened beverage in the same model, then you subtract one from the other and you find out what is the statistical substitution result, like if those people who were on sugar sweetened beverages switch to locally sweetened beverages, what would be their risk reduction. However, the issue is the majority of cohorts have reported per-serving association individually for sugar-sweetened beverages in outcome or non-sugar beverage in outcome, and not the substitution analysis. So is there anything we can do to actually use that data? And this is just stage one. So this is not collecting data from the cohort. This is from publications. So that's why we call it meta substitution. It is similar to what Walter presented yesterday, but slightly different, the approach is. So can we use separate models? So for example, I'll give an example here. UK Biobank, for example, for total mortality, have published both in one paper. They published both a separate analysis for SSB and SB for total mortality, and also a mutually adjusted model where they put both SSB and NSB in the same model. And the substitution HR for adjusted is 0.61, and then we calculated from the summary data a substitution HR of 0.65, which is very similar. And there are some assumptions that we had to make, but I'll explain that. It means that they're so similar that the summary, it appears that the HR is slightly changed, but they're very similar. So the substitution effect from summary data is possible, and it's robust, and it validates our approach. There are two considerations here. One is the covariance issue. So when you actually measure two estimates together, they either move in the same direction. So that's positive covariance. So if they move in the opposite direction, that's negative covariance, or they move independently, that's zero. It matters in substitution because the covariance term affects our confidence interval, and we need to know the covariance of the local sweetener and SSB. I think for the potato paper, the Harvard one, you already had the covariance measured from the actual cohort. But over here, we can't do that because we only have the summary data. So how do we do it? So if we assume there is no constraint, for example, each is analyzed separately. So there's an SSP model, there's an NSP model, they have different reference groups. If you say covariance is zero, it will be a biased estimate, and that's an issue. The confidence intervals will be very narrow, and we can't use that. However, we have to know what the covariance can be. What is the assumptions? Is it plus 0.2, 0, minus 0.1? So it's something called beverage constraint. So when we have both beverages in the same model, the total amount of beverage remains constrained. It's same. So if the association SSB is high, if it's more harmful, the association of NSB must be lower, because they both compete to explain the risk. So when they're competing, if you put in the same model, if SSB is very high, the NSB will be slightly lower, and this leads to a negative covariance. So in general, across some studies which they have reported, it's around from minus 0.2 to minus 0.3, and that's generally accepted to be a negative covariance for these two beverages. So we took that minus 0.2 as our main covariance for our analysis, but we are also looking at other assumptions like minus 0.3 and minus 0.5 to assess robustness. I showed you the UK Biobank data, where we showed with the covariance, actually it's very, very similar. So what we did was we identified mutually adjusted models, then we extracted separate models, and also then standardized the models to 250 ml, and then applied a sensitivity analysis of robustness. But today I'll only report the minus 0.2 covariance model results. So what we did was we did study by study substitution. So both the study has to give NSB and SSB data, We didn't do a pooled analysis and then pool them, because then there are other issues related to just pooling SSBs, just pooling NSBs, and kept putting them to, and then doing a meta substitution on the pooled results, where if the population, there is a population difference between the two different estimates, then you don't know if the results are from a population difference or actually from the difference between SSB and SB. So we actually did a paired analysis. Paired means in a sense that every study was substituted within, and then that substitution result was pooled. So we used fixed effects pooling, then we did correlation assumptions, modeling approach was so there are subgroups, random effects which I won't present today, and then heterogeneity I-square, and we assessed publication bias and grade. There's another approach that we will be doing, which is similar to what Walter presented, which is pooling across studies, but we'll be using a multivariable approach. The advantage is that it can use covariance from other studies to inform the overall covariance. So that is one approach that can also, if the results match, that will also ensure that our main approach is correct and robust. So as I showed, this was the result that of the original substitution meta-analysis from Jen Lee, which was published. And these are the cohorts which we have used for our meta-substitution analysis. So these are Harvard cohorts, Women Health Initiative, UK Biobank, EPIC, Lifelines cohort. And if you can see the green, the blue means a substitution analysis. We took this, if the substitution analysis is present, we took it. And we didn't update it. And the green is mean that they don't have a substitution analysis. Either we use the updated one, or we actually did a multi-substitution analysis. For, I think the Harvard one is wrong, the type 2. We did 2 analyses, but I'll present the first one. We actually used the substitution analysis that was reported. So blue ones means if they reported substitution analysis, we used it. Green ones means we actually calculated it. And these are the results for the meta-substitution analysis using a covariance correlation of minus 0.2. It's from 8 mega cohorts with almost 1.4 million participants. And we see very similar results for local restricted impaired visit to SSBs, reduction in body weight, CHD, not reduction, but the association of lower body weight, CHD, CVD, and total mortality. Type 2 diabetes is on the cusp, but if we update the meta-substitution using updated data from Harvard cohorts, it actually becomes like it shows a lower type 2 diabetes, but at the moment it is on the cusp and it's not significant. And for substitution of water versus SSBs and local sweetener versus water or reference substitution, we have very few studies to look at, but they are neutral. So these are the results of the meta substitution. So currently, we established the methodology. We have calculated or estimated the RRs. The covariance approach has been validated. We have pooled the results, and next we'll be doing a sensitivity analysis using multivariable meta-analysis, subgroup meta-analysis, and also dose response we want to do, and then risk of bias grade, and then manuscript. And so this is what we actually only use published data for this meta-substitution. Our aim now, the next step, and if you see here, the number of studies and outcomes missing is very large. But we have 15 studies that we can actually approach. So the next step is engage with all the mega cohorts to strengthen the substitution analysis evidence. Either we approach them, we are approaching them to give us the data, or we can help them do an analysis and then we can put it in the 2-stage model. I'm willing to help them on a cohort-specific analysis to be able to publish on this. I know there are a lot of cohorts which have the data, but they haven't published it. It will be nice to have it published and also included in this analysis, and integrate these findings into comprehensive mega cohort synthesis, which will hopefully inform guidelines. If we include all the 15 mega cohorts with all the number of people, we are getting around 4 million people with substitution analysis results and change analysis results. That will be a very strong evidence for robust methods, using robust methods to show that local sweetened beverages, when they actually replace sugar sweetened beverage, and that is what the public health question, then you see a benefit. So I will end here, and I acknowledge all the team, and then John has more names here, so if I missed anyone, I apologize for that, but thanks for having me.